All of our dreams come true if we have the courage to pursue them. Walt Disney. Good evening to everyone. A warm welcome to our respected director, chief director, deans, faculty, students, and external participants. A very special welcome to our chief guest, Professor Jay Raghunathan, and today's resource person, Dr. Pawan Kumar. I feel privileged to host this 21 days online international FTP on data science tools and events. I hope this event will be helpful for all of us to develop our knowledge. Without any further delay, we can begin our inaugural function. Now let us start our function with Tamil Thai Varthu.
Armadi. Sarmida.
Hello, sir.
Yes.
Good evening, everyone. Now we'll start with the Tamil Thai Valthu. நீராறும் கடலுடுத்த நிலமடந்தை கெழிழொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிது தெக்கணமும் அதில் சிறந்த திராவிடனர் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திழக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வாழ்த்ததும் வாழ்த்ததும் வாழ்த்ததும்.
Thank you, Sharmita. Now I would like to call upon our head of CSE department, Dr. S. Kanagasubaraja, to deliver the welcome address.
Very good evening to all. I welcome you all to our International Faculty Development Program on Data Science Tools. This Faculty Development Program will be conducted for 21 days from today to 1st August 2023. It's my great pleasure to welcome our chief guest, Professor Jay Raghunathan, Assistant Head, School of Ocean Technology, University of Newfoundland, Canada. Thank you, sir, for accepting our invitation and joining with us. Welcome, sir. I'm happy to welcome our today's resource person, Dr. J. Pawan Kumar, Department of Computer Science and Engineering, NIT Trichy. Welcome, sir. I welcome our Chief Director, Dr. N. Seduraman, sir. In spite of his busy schedule, he has joined our inaugural session. Welcome, sir. I welcome our Director, Dr. N. Malmurugan, who encouraged us and extended his support for conducting this FPP. Welcome, sir. I welcome our beloved Dean, Dr. R. Jagadish Kannan, who is a big source of inspiration for us. Welcome, sir. I welcome our Dean, Research and Academics, Dr. A. Krishnamurthy, sir. Mrs. Sridevi, ma'am, General Manager, SRM Group of Institution, Tiruchirappalli Campus. Mrs. Abhirami, ma'am, Establishment Officer, SRM Group of Institution, Tiruchirappalli Campus. Our Associate Dean, Dr. Balasundaram, and Head of various department, faculty members, and students. Finally, and most importantly, I welcome all the 600 participants who have registered from across the globe for this FTP. 350 participants registered from outside Tamil Nadu and 5 from other countries. The 600 participants have put their trust on us to learn data science tools. So in this juncture, I assure that this FTP will satisfy your expectation and you will gain a lot. Thank you for your support and encouragement. I welcome you all. So according to one data science survey, so in the year 2025, around 200 job opportunities are estimated to be available for data science professionals in India. So according to this trend, our FPP will cover 21 important data science tools which are widely used in industries. I sure this FTP will be useful for everyone, particularly students, scholars, and faculty members. So once again, I welcome you all. Thank you.
Thank you, sir. Now I'm delighted to call upon our honorable delegates to light the Kuttavalakku.
So now I request our chief guest, Dr. J. Raghunathan sir, to light the lamp. Sir. Yes. Yes, please. Thank you, sir. Now I request our chief director, sir, to light the lamp.
Okay, done.
So now I request our director, sir, to light the lamp. Yes, sir. Click. Yes, sir. Thank you, sir. Now I request our dean, sir, to light the lamp. Yes. Thank you, sir. Now I request today's resource person, Dr. J. Pawan Kumar, sir, to light the lamp. Yes. Thank you, sir. Thank you. So, thank you.
Thank you, sir. Now I would take this opportunity to call upon Dr. N. Sethuraman, Chief Director, SRM Group of Institutions, Ramapuram and Tirsi Campus, to deliver the presidential address.
Very good evening to, am I audible?
Yes, sir.
Very good evening to everyone present in this, for this International Faculty Development Program organized by the Computer Science Department of campus of SRM IST. I am proud to be a part of this program by proceeding over this International Faculty Development Program. For the I salute our chief guest, Professor J. Raghunathan, for having accepted to deliver inaugural address. And also, I welcome Professor Pawan Kumar, Humanities Trichy, and my colleague, Dr. Malmurugan, Director of Trichy Off Campus, and recently joined Dr. R. Jagdish Kannan, who is also equally interested in organizing such a kind of national and international seminars. He being known to the academic circle as an academician interested in organizing this program. For the information of our chief guest and Professor Pawan Kumar, Professor Kannan Subbaraj, earlier he was in Ramavaram as managing the Department of Artificial Intelligence. And we have chosen him to head the computer science department in Trichy Engineering College of the off-campus of IST for two reasons. He has got wide experience. Now, this is the first event organized by him. I don't know whether distinguished chief guest and Professor Pawan Kumar, you may be knowing about SRM. It is known internationally. This off-campus is the youngest child of SRM IST, namely known as SRM University. We have main campus in Katangulathur, Ramavaram, Vadavalani, Delhi, Modi Nagar. Last one is, I will not say the last one, the last child is Trichy off campus, inaugurated by Honorable Vice President of India, Mr. Venkaiah Naidu. Though it is 2 years old, it has got tremendous growth. And our faculty members are also interested in doing a lot of research activities. And our chairman and co-chairman, they are very particular about taking this off campus to move forward. Now I am happy that today it is being inaugurated. See, the topic chosen is data science. It's a large volume. Why it is being taken up today? Maybe to extract some meaningful insights. You all know it plays a very vital role in facilitating the organization, in facilitating the institution, even individuals to take a decision, particularly business decisions, planning, monitoring, even future forecasting. I'm happy that we have about 600 participants across the globe. And it is a long period of 21 days. I definitely hope this FDP will throw light on various issues as we are going to, as the participants are going to listen to lectures to be delivered by prominent faculty. Thereby, they will be able to know how to solve the real-time problems. That is more important. Definitely, students will also be benefited. I have a strong hope that in these 21 days, various issues will be taken up for discussion that will be useful to the faculty. Incidentally, students are also permitted to attend here and there so that they will also get some benefit. I appreciate the efforts taken by the Dean and his colleague, and I thank distinguished chief guest, Professor Jai Raghunathan, and resource person, Professor Bhavan Kumar, for having come today to offer presidential inaugural address as well as to act as a resource person by Bhavan Kumar. You all know SRMIST is known for its contribution in the field of research. We have students from all over the country, even students from other nations also. As far as Trichy campus is concerned, this is the first event covering or permitting about 600 participants to participate in this event. I hope it will be a fruitful and useful one. I thank Professor Kanaga Subraj and Dean, Director, for having given me an opportunity to preside over Chief Guest and Professor Bhavan Kumar. I may be excused. I have got another meeting by 7:15. I will not be able to participate beyond that. Now the forum is open for the Chief Guest. Thank you. Thank you.
Thank you,
Thank
sir.
you, sir, for providing us with your valuable time. Now I'm delighted to call upon Dr. N. Malmurugan, Director, SRM Group of Institutions, Tiruchirappalli Campus, to deliver the felicitation address.
Very good evening. Am I audible, sir?
Yes,
Yes.
So respected Chief Guest of this evening, Dr. Jai Raghunathan, Assistant Director, Department of Ocean Technology, Memorial University of Newfoundland, Canada. Respected Chief Director of our SRM Group of Institutions, Ramapuram and Tiruchirappalli Campus. The speaker of this evening, beloved Professor Dr. Bhavan Kumar from NIT Tiruchirappalli, Dean ENT of SRM Tiruchirappalli Campus, Dr. Jagadish Kannan, HOD and organizer of this program, Dr. Kanas Baraja, my dear colleagues and the participants from various parts of the country and from the other countries also. At the outset, I'm very happy to be part of this program. As rightly said by our Chief Director, this is the first program of this much big size with more than 600 participants from all over the globe. And I'm also joining my hands with the Chief Director in welcoming our Chief Guest, Dr. Jai Raghunathan, sir. He joined with us in his busy schedule. The very first day of this 21-day long FDP on data science tools. Data science is now a new buzzword. Data science is not new one, but data science is now new buzzword. Even we have used tools like Excel for managing data. But now the tools are not sufficient even with Excel because of the structured form and unstructured form of the data, and because of its volume. Now we are talking about big data, and we are going for more applications, and we are in the position to analyze the data after collection and to extract what is required for us for making decisions now. Now this field is called data analytics. There are many tools in data analytics, many tools. But almost all the tools are mostly on either on statistical base or on how to use different applications, API based. Suppose we look at TensorFlow. TensorFlow is a popular tool we are using in machine learning. If you look at the ACIS, it's a tool, right, with mostly coming from statistical calculations. So how to go for forecast or predict something from the data is now the big question, not only in applications of engineering, but also in business. So with available data, what we can do? With available data, right, how we can go to get a useful parameter for our business. So this is now, right, the big question in front of us with the data. Data is coming from all sources. There are many sources now. Everybody is now giving data. Even a student, they are using Facebook, they are using other social media, and they are generating more data every day. So the big data is coming now from everywhere. Now the question is how to analyze the data and how to use it for further process. Now this is now the big question in front of us. All the data scientists or data engineers are doing some job on this one to help the business people and to help the engineering applications team. And in this right current scenario, our SRM Institute of Science and Technology, Trichy campus, organized this wonderful FDP on data science tools. I should appreciate the efforts taken by our Dean, Dr. Jagadish Kannan, and our HOD, Dr. Kanasupuraja, for organizing this wonderful, or I can say rather, the most wanted FDP, not only for the teachers, but also for students and for practice engineers, how to go for various types of tools used in data science. So they're going to cover 21 tools, each one on one day. I request all the participants try to get maximum benefit out of this 21 days FDP, and please get to know about the latest tools available in data science. And from today onwards, every day there will be one tool. It could be SAS, I told you earlier, or it could be BKML, or it could be anything, any type of data science tool that we will discuss. Please get to know about the new technology, get to know about new tool, and later please use it in your engineering applications, and try to excel in this one. So I once again congratulate all the organizers for organizing this wonderful event. And I like to request all the participants, please make use of this program all these days from all the various types of experts who are going to give their expertise in all these days. So thank you for the opportunity given to me.
Thank you, sir.
Thank you, sir. Now I'm honored to call upon Dr. R. Jagadish Kannan, Dean ENT, SRM Institute of Technology, Trichy campus, to address the gathering.
Good evening to one and all present here. Honorable dignitaries, Chief Director, sir, Director, the GM, Madam, the esteemed faculty colleagues, HODs, and my dear participants. A very warm welcome to all of you on this auspicious occasion for the inauguration function of 21-day online international faculty development program on data science tools. It's indeed a privilege to present before you today and extend my heartfelt felicitations to each one of you who have joined us for this enriching journey. Data science has become a vital discipline in today's fast-paced world where information is generated at an unprecedented rate. So as we strive to make sense of this data and we need to extract meaningful insights from the data, it is very imperative that our academic institutions equip their faculty members with necessary tools and knowledge to effectively engage in the field of data science. The faculty development program, so what we are organizing from today to 1st of August, will serve as a platform to bridge the gap between the ever-evolving world of data science and our esteemed faculty members will make use of this opportunity. So the workshop or this faculty development program aims to empower the faculty colleagues with the latest tools, techniques, and methodologies that will enable the faculty members to inspire and educate them the next generation of data scientists. The data science, with its immense potential to revolutionize the industries and transform the decision-making process, demands continuous learning and adoption in the field of DS. The field of data science tools is constantly evolving, and it is our responsibility to ensure that our faculty members, the student friends, research scholars remain at the forefront of these developments, and we need to solve certain open-ended problems or open-ended issues. This faculty development programs seeks us to equip the faculty colleagues with the skills to navigate this dynamic landscape, enabling you to impact the cutting edge knowledge to their students. So ultimately, the FDP is organized to transform the knowledge from the faculty colleagues to the student friends. So through this program, so we intend to create a collaborative environment where faculty colleagues can exchange their ideas, learn from each other, from their experiences, and try to create a culture of innovation. So with the data science tools. So we firmly believe that by investigating our faculty's professional development, so we are investigating in the future of our educational institutions, and more importantly, in the success of our student friends. So the significance of data science in various domains cannot be overstated. So it starts from healthcare to finance, from marketing to transportation. The data science has its potential to revolutionize every industry by their technologies. So by embracing data-driven decision making, we can enhance the efficiency, reduce the cost, and unlock new opportunities for the growth and development in the field of DS. So as a conclusion, I would like to express my sincere gratitude to all the participants who have taken the time to be part of this faculty development program from today to 1st August on data science tools. So I extend my appreciation to the organizing committee, especially to the HOD and the team, and our distinguished guest speakers, the chief guest of the day, who have graciously agreed to share their expertise and insights. So I urge all the participants to make the most of this opportunity to engage wholeheartedly in the sessions and to actively contribute to the discussions. So together, let us embark on this transformative journey, equipping ourselves with the tools, knowledge to shape the future of the data science education. So thank you. I wish you all a fruitful and inspiring faculty development program on data science tools. All the best.
Thank you, sir.
Thank you, sir. It is my honor and privilege to call upon Professor Jay Raghunathan, Assistant Head, School of Ocean Technology, Memorial University of Newfoundland, Canada. He has graduate degrees in Electrical Engineering and International Business Management and bachelor's degree in Electrical and Electronics Engineering. He is also the gold medalist in his graduate degree in Electrical Engineering. He was the first recipient of the Marine Institute Vice President's inaugural teaching award. He has served as a chairperson of ROV program for over 8 years and is currently serving as the coordinator of programs at the School of Ocean Technology. Besides his teaching career, he is an entrepreneur and has invented technologies such as Mantra Box and the RFID music player. We are delighted to have you as a chief guest, sir.
Sir, unmute, sir. Sorry, sir. Raghunathan, sir. It's not audible. Unmute. Stop.
Audible to everybody.
Yes, yes, sir.
Thank you so much. This is the technical glitch. You know what they say these days? Information is power and data is money. There's no questions in my mind. The future lies in data. There's an example before I start my speech. Say Cisco Systems made hardware for data to flow through them for years. And only if somebody at Cisco thought, hey, we are looking at the pipelines that carry data. What about the data itself? Then they would have been the Google today, right? So data is money. Respected SRM management and the academic management group, faculty, and my dear students, I'm immensely happy to join you in this inaugural function of the Faculty Development Program. And I hope that in the next 5 to 10 minutes, I can inspire you with some of the knowledge that I've gained on higher educational institutions. I glanced through SRM's mission and vision, and I'm so happy that they are on to a journey with 3 critical components: people, process, and technology. Now, the million-dollar question is, how can faculty contribute to this goal by making that remarkable journey toward it? So, if you look at the UN's recent directive on higher educational institutions, there are 2 main things that are highlighted. One is social innovation, and the other one is sustainability. We're competing for world rankings with one another. And the UN's directive now changed that aspect toward looking at developing sustainable societies around you and innovate the social component in which place where your university is located. So the cornerstones, I believe, to achieve those directives is through innovation in teaching and learning, research, and public engagement. So these 3 components are essential for higher educational institutions to achieve these goals. Now, if we talk about teaching and learning, for example, what does the world demand from a student? A globalized student. Right? What is a globalized student? What does that mean? A student who understands and possesses the skills he or she needs to thrive successfully around the world. And what components they may need to thrive is cultural competency, worldly knowledge of technology, data-driven decision-making skills, and also social IQ. Now, these are the skills that are expected from a globalized student. And how can faculty contribute toward that? The control that faculty has is over curriculum. So a lot of reforms have to be done via curriculum in order to make curriculum so friendly to graduate a globalized student. And there are opportunities within the curriculum and through the institute industry interactions and also communicating with universities around the globe. This can happen very easily. And also looking at the process of innovation that would happen in higher educational institutions, looking at the process from student admission all the way up to graduation and creating new methods, new ways of doing things, and more efficiently and more beneficial to the society at large, as well as the people, the faculty, the support staff, and the management, is another way to look at doing things very differently when it comes to students. Now, another 2 main themes that are emerging around, at least around the Western universities, are entrepreneurship and innovation. So universities are transforming themselves into what they call as an entrepreneurial university. What does that mean? That means that university wants to graduate entrepreneurs, right? The students who would go work in the industries, but instilling that entrepreneurial mindset among the students, because This is this again comes from the UN's directive of sustainability. Right? If you have to revive the society around you, so you need to create an impact. And how do students create an impact? By becoming entrepreneurs or going into the industries with an entrepreneurial mindset that does wonders to the industry, that grows businesses, that brings businesses, that creates job opportunities, and your financial metrics will grow exponentially, and thus transforming the society that you live around. So faculty has got a large contribution in teaching and learning environment in order to achieve that goal. And the second pillar that I talked about is research. So right now, the world rankings demand one of the metric that goes into world ranking is the number of publications that come out of the university. But I can challenge you. I call that as a vanity metric more so than papers that make real impact in society. So there should be a culture fostered within researchers to produce papers that make direct impacts in the society. So when you write a paper, I would want you to think, what is the social benefit? Not indirectly, but directly. A lot of the research that goes on these days is about optimizing a process or increasing the efficiency by 1% or 2%. Where is social innovation here? Right? What impact are you creating? Direct impact are you creating with the society? Right? So those are questions that I want you to ponder when you write your research papers. So if all universities are doing a great job, so my question is, how come the world global problem still exists? Climate change, hunger, obesity, sustainability, waste management. These are world major problems that still exist. There is no degrees that any universities offer on climate change or obesity or world poverty. So what should we do as an university in order to attack these global problems? The key aspect is multidisciplinary research. SRM focused on the computer science and technology department. It's a great way for any computer student to branch out into other departments and do multidisciplinary research. So these world major problems cannot have one pronged approach. They need multi-pronged approach. And you cannot build that solution without the help of research that happens in other disciplines. Now, instead of thinking about your own area, and I'm guilty of that as an electrical engineer, I will focus on motors and improving efficiency on the motors and apply fuzzy logic or artificial neural network or genetic algorithm and then multiply my papers. Instead, if I start looking at how can I apply my knowledge in electrical engineering or technology, towards, solving global problems, then there's an opportunity to do multidisciplinary research. I always say data is all around us. A lot of people come and say there is no data for me to interpret. I don't believe that. Hundreds of years ago, with no tools, no instruments, and man in Greece was able to measure the circumference of Earth just based on the shadow a stick would cast when the sun was directly on the top, right? So 800 years later, with the invention of instruments and whatnot, they came in at much worse margin of error. But what it tells us is we have to identify creative ways to measure things and looking at the data creatively and what data would be useful and what we can interpret with the data and how we can make an impact, meaningful impact is absolutely important. Third pillar is about public engagement. I encourage the universities to involve public, involve institutions around you, industries around you, and form that ecosystem, sustainable ecosystem in order to foster research. A lot of research happens in isolation, and not much greatness can be derived from those research. So public engagement becomes crucial. STEM education concepts involving school students some way in your university to create awareness among data visualization and data interpretation is equally important. Those are your future warriors and your supporters for data management and data visualization. I am involved with the Tamil Nadu government and the South Indian Chamber of Commerce and Industries on trying to set up an ocean technology park in the Indian Ocean for our country. And believe me, there is a lot of data in the ocean, as there are oceans of data. So there is much opportunities for those graduates to be able to participate in interpreting data that comes out of the ocean, because we know very little things about the ocean. And if flight disappears, we still can't locate it. If that flight disappeared on Mars, we would have found every piece of it. The Ocean Gate sub went down, and it took us a very long time to figure out what happened. And what's missing in all of those things, and you see incompetence around the world, it is data. So this workshop, I hope, will help all the faculty and the students to shed some light on not alone visualizing data, and also look at what data you need for a certain problem. How do you measure the data to identify the right solution for it? Somebody came to me, asked me one time, sir, we want to figure out how do we measure teaching effectiveness for the faculty. Have mechanisms like feedback from the students, feedback from the peers and other things, but there's a lot of data that we have to look at in order to interpret the teaching effectiveness. Well, I said, let's record the classroom lectures. We'll tell them it'll be randomly recorded. And we looked at snippets of those videos and see the quality of the interactions that happens between an instructor and the students within the classroom. That shed us a lot of light to see the quality of teaching and learning in that environment. Right? So I always say data is all around us. We don't have structured data. If you want to measure something, look carefully what data you need before you interpret it. With that, I would like to conclude, and I'm so happy to be a part of this event. Thank you.
Thank you, sir.
Thank you, sir, for your valuable inputs and suggestions. Now I would like to call upon Dr. Balaji to propose the vote of thanks.
Balaji, sir. Balaji, sir, is audible? Balaji, sir.
ஹலோ சார் கேட்கல என்ன பேச இப்ப கேக்குதா? Am I audible?
Yes, sir. Yes, yes.
Yes, sir, you are audible.
Yeah, good evening to one and all present here on this memorable occasion. I deem it a great honor and privilege to deliver the vote of thanks in this memorable occasion. First of all, I would like to thank our today's chief guest, Mr. J. Raghunathan, Assistant Director, Department of Ocean Technology, Memorial University of Newfoundland, Canada, for spending his valuable time with us by delivering a very insightful session on the use of data science tools in the modern era. And I would like to express my heartfelt thanks to our Board of Management for providing us this excellent infrastructure for providing events like this. And I would like to express my heartfelt thanks to our beloved director, Professor N. Malmurugan, for continuously guiding us in conducting events like this. I would also like to express my deepfelt thanks to our beloved Dean, Professor R. Jagadish Kannan, for constantly guiding us and motivating us greatly to achieve greater heights in all aspects of life. And I express my profound thanks to Professor S. Kanaya Subbaraja, Professor and Head, Department of Computer Science, for motivating us in building a team to conduct events like this. And I also express my heartfelt thanks to all the colleagues, faculty members, non-teaching staffs, and administrative staffs for providing us valuable time and guidance in conducting events like this. I also thank our today's speaker, Dr. Pavan Kumar, for going to give a nice session on mathematical models of data science. Thank you all the participants, and I request all the participants to use this opportunity to gain deeper insights into the various data science tools. Thank you one and all. Thank you.
Thank you, sir.
Thank you, sir. It is time for us to lend our ears to the speaker of the day. I'm extremely honored to call upon Dr. Pavan Kumar, Assistant Professor, NIT Trichy. He has done his BTech in CSE in JNTU Hyderabad. He has done his MTech in CSE in JNTU Hyderabad. He has done his PhD in NIT Warangal. He is currently Assistant Professor in NIT Trichy. He has organized various workshops and conferences. He has also done various publications as well. Now, I'm very much delighted to have you as our speaker, sir. Welcome.
Thank you. Audible, sir?
Yes, sir. Yes, sir. Yes.
Is my presentation visible, sir?
Yes, sir. Yes. Slide is visible.
Is it in full screen, sir?
Yes, sir.
Yes, sir.
Yeah. Welcome to the workshop. Actually, the name of the workshop is 21 Days Online International Faculty Development Program on Data Science Tools. Somebody might be surprised that what's the topic for first session. The topic is foundational mathematics for machine learning and data science. So in this particular one, how you can consider or what you can get out of this so what we can get out of this session is basically by end of this 55 minutes or around 50 minutes, we will be realizing that mathematics is one of the important tools for data science. This is one thing that I want to convey. With that motivation, we will be starting today's session. Now, in this particular one, foundational mathematics for machine learning and data science. Usual question that we will be getting or anyone will be getting is why mathematics is required for machine learning or data science. This is first question that I am going to answer. Second question is, if mathematics is required, what kind of mathematics is required? These two questions I will be answering in this particular session. So first of all, let us consider our traditional programming, where we will be having the program and we will give some data as the input, then we'll get the output. Basically, in one view, what we can consider is program and data both are inputs for the computer, then we will get the output. This is what we used to practice from years. I hope most of the participants are having some programming language background. That's why this I have taken as the initiation or what you call starting point. Next, coming to the machine learning, here we will not be having the program, we'll be having the data, and the output also will be having. By using this, we will be generating programmer rules. What is the purpose of this one is, by using the generated program, or we can say that one as a model, we could able to predict the output for the new input. This is what overall difference between traditional programming and machine learning. Now we consider in this the first question was, why mathematics is required. In this particular one, as the insights given from chief guest of today and other speakers who have delivered their speeches, they have mentioned that data is important. Now, since data is important, we need why data is important. First of all, is from the data we will be deducing something or some useful information. That useful information we wanted to use for commercial purpose or some what you call utility purpose. This is what overall intuition. Now, once if you have the data, if you have some data, then how we can deduce some useful information. This is another thing. The data you can get from, as chief guest mentioned, data you can get from ocean, data you can get from what you call movie industry, you can get from some other industries, from anywhere you can get the data. Nowadays data is flowing like a stream. Now you consider, once the data is given to us, then how we can reduce, or how we can convert that, or how we can extract useful information from it. How we can reduce is, let us assume from ocean we have got some data. From that data, how we can reduce useful information is, we need to have some what you call prior idea about what kind of data we are having, from where we are getting all those that what you call domain specific information we need to know, so that we can convert that available data into useful information. But what mathematics will do is, without having much knowledge about the domain, we could able to generate useful information. This is what the beauty of mathematics. That's why I'm considering, or we can consider this mathematics as a tool for the data science. I'm repeating once again, because this is the main point where all need to get motivation. Like we are having the data. From the data, what is the ultimate goal for us is, we have to generate useful information. But without having what is the domain, from where we have got the data, what kind of data we are having, all those more domain knowledge, we cannot make it. But by using mathematics, without having much knowledge about domain, we could able to deduce useful information. This is the clear motivation for what you call considering mathematics as a tool for the data science. Is it clear, sir? Shall I continue with this? Yeah. Now, see, the goal of this machine learning or data science is to design general purpose methodologies to extract valuable patterns from data, ideally without much domain specific expertise. We need not know what is the domain background and all. Next, this is another important consideration that we will be following in entire presentation. That is, In general, we'll be having data in a different forms. Like we can have text data, we can have numerical data, we can have some image data, image also as a data, all these things. But while considering, coming to our talk, we'll be considering data as numerical. Even though the data is not numerical, we will be considering, or we will be converting that data into numerical form. That is what our assumption in throughout presentation. So now you consider what are the basic the first question that I want to answer is why mathematics is needed. This is the background for that. This is the motivation for learning this mathematics. Then second question that I want to answer is what mathematics we should learn. What mathematics, in the sense there are certain domains I have segregated like this. This is not the formal segregation, just I have segregated in this way. Linear algebra, analytic geometry, probability and distributions, optimization, vector calculus. These are some of the areas which we need to learn in order to what you call cope up, or in order to use mathematics as a tool. If you learn these concepts, then we could able to make mathematics as a tool to deduce some useful information from the data. This is what the idea. Now let us consider some insights into these. We cannot cover all these topics in 1 hour or 50 minutes, but I will try to give some of the topics which we need to learn in order to start working with this data science by having mathematics as the background. Yeah, linear algebra. Let us consider linear algebra. In this one, what is meant by linear algebra? First of all, in general, we have learnt in childhood, in schooling or college, we have learnt linear algebra. What is meant by linear algebra is just it is a study of vectors and matrices. It is nothing but a linear algebra. We can say informally like this. Now, what we will do is whatever the data we are having, that entire data we will be representing as vectors. That collection of vectors we will consider as matrix. That I will show you the example, of course, in later slides. Now, basic idea is we will be storing data as vectors. Why we need to store data as vectors, and what is the advantage that we will be getting? What we will be doing with those vectors is just if you consider two objects we represented as vectors, two objects, then whether these two objects are relevant to each other or not, we have to find. How we can find is just we will be performing some operations in between these two vectors, so that we will come to know what is the similarity between these two objects. This is what the intuition for representing the data as a vector, right? We will be seeing one example as well. And with this intuition in linear algebra, we will be concentrating on these topics: vector, matrix, group, system of linear equations, linear combination, linear independence, matrix inverse, Gaussian elimination, basis. These are the topics which are useful while dealing with mathematics and the data science. Yeah. Coming to vector, as we know what is meant by vector in mathematics. What is meant by vector in general, we will be having two components. One is magnitude and the direction, and another one is direction. So magnitude will be having and the direction will be having. So now if you consider mathematics definition, we will be having magnitude, direction. Now computer science, if you consider, it is simply a one-dimensional vector, one-dimensional array. Now if you consider vector in mathematics, is it same as computer science? Whatever the vector we are considering is absolutely both are same. In mathematics, we will be representing vector by having two things. One is magnitude, another one is a direction. In computer science, same thing we will be representing as single dimensional array. Okay, in general, we will be representing the single dimensional array in either row form or column form, but our convention is to use column vector. Row vector, column vector, you might be knowing. So our convention is to use column vector. If you want to specify it as a row vector, then the same column vector transpose we will be representing, and we will be considering this as the vector. So now basically whatever the data we are having, that we will be representing as a vector, and that vector is nothing but one dimensional array. Okay, this is what we have concluded now. Next, if you consider earlier intuition, what are the what is the advantage of representing data as a vector? Is we will be performing certain operations between vectors, so that we will come to know what is the similarity between those vectors. This is the idea. Now, how we can interpret a vector is, we can interpret in one way. It is a point in a space, like you consider just a two-dimensional space where we will be having x coordinate, y quadrant, we will be having, then 3 comma 1 is 1 point. So in this particular space it is 1 point, 1 comma 2 is another point. Likewise we can consider vector as a point in a space. Now if you consider three-dimensional space, three-dimensional space means how many values we need to have? Three values we need to have. Let us consider 1, 5, 9. These are the three values, so that we'll come to know this is the point we are representing. So in space, okay, three-dimensional space, we will represent vector as a point. Similarly, you can imagine or you can assume more than three-dimensional. In general, we might have encountered up to three-dimensional, but n-dimensional space also exists virtually. Yeah. So n-dimensional space, how many values we need to know? In two-dimensional space, 2 we require. In three-dimensional space, 3. In n-dimensional, we require n values to represent one particular point. Point is nothing but the vector, so we can represent a vector in n-dimensional space with n values. This is what the conclusion. Now if you consider this two-dimensional, we are having only 2. In n-dimensional, we will be having n values for one particular point, and that n-dimensional space we will denote with r power n. This is the representation we will be using for n-dimensional space. Okay, in general we will be having the data which is in n-dimensional space. That's why it is very important aspect that you need to understand. R power n, what is this? R is real values. As we have assumed that entire data we will be considering as numerical data, so that numerical data can consist of real numbers. So here 0 0.1, 9.7. Likewise we can have 1 point that we will represent as a vector. So r power n means n quadrants we will be having. So in the n-dimensional space we will be representing a point as a vector. This is one way of interpreting the vector. Next, second interpretation of a vector is the direction. So if you consider 3 comma 2 or 3 comma 1, wherever whatever we have considered earlier, 3 comma 1, here we are having at the direction, like towards x quadrant we are having the direction 3, towards y we are having 2. Likewise for n-dimensional space we will be having direction with respect to all the quadrants. This is what the second interpretation of a vector. Next, the operations that we will be representing, will be performing in vectors. There exist several operations. One of those is vector addition. Now you consider one vector is there. Pick this diagram you consider. Now you consider two vectors are there, u and v, and for each vector we are having a direction, and you can consider this as the tail, this as the head for this vector u. Similarly, this is the tail, this is the head for the vector. Now, if you attach one tail to the another head of the another vector head, then it will be considered as addition of both the vectors. Now, if you consider this one, this tail you attach to head of the u. You consider the diagram C. Here we have attached V's tail to U's head, so that we have got the direction for U plus V. This is addition. Now we wanted to perform subtraction. Subtraction in the sense, just what we will do is whatever the V we are having, that V's direction we will change. Direction, just to assume this V's head is here, tail is here. Instead of head here, tail here. Now we are assuming here there is a head, and here there is a head, and here there is a tail. Now we wanted to perform addition. Addition, what we will do? Just we will be attaching one vector's head with another vector tail. Just you attach in this way, like V's head you attach to U's tail. Then U plus V, it is nothing but U minus V. That is what the addition. We are performing addition only, but that you can interpret as a subtraction. Like this, we can perform vector addition and subtraction. Now, in Python, we are having some libraries where we can represent directly vectors as an array. As we have mentioned, single dimensional array. We can represent array 1, 2, 3. So, three-dimensional space, we are having a point and we are considering this as the vector. This is another vector and we are adding these two. That's it. Next, now this is an important understanding that everyone should know before using data as what you call the input. Now you consider now a geometric representation of these vectors. How we can represent is, let us consider well-known iris data set where we will be having these four as the columns which are available, and this is the class label. Now out of these I columns which are available, these four are the features. By using these features, we could able to get this particular class label. This is what overall idea of about this data. Now if you consider how many instances of this data we are having is 1, 2, 3, 50, so on up to 150 we are having. So these many instances we are having, and how many features we are considering is 4 features we are considering, and the class label we are having here. Now how many number of columns except the class label, that we will consider as the dimension of the what you call geometric space. Like we have considered n-dimensional space, 2-dimensional space, 3-dimensional space, right? So here we are having 4 features. So our 4 columns except class label. So 4-dimensional space we need to consider, and each dimension will represent one particular attribute value. Okay, like in 4-dimensional space we require for a vector we require 4 values. Those 4 values are for instance you consider 1, 5.1, 3.5, 1.4, 0.2. These are the 4 values which we will represent to say one point in 4-dimensional space. Likewise, how many points we are having in 4-dimensional space is 150 points. Okay, this is nothing but what you call interpretation of data. Suppose the data is available with us, then how we can interpret that data and how we can represent that one as a vector is, just we need to know how many features are there, how many rows are there, how many features are there. Those it is directly related to what is the n-dimensional space, what is the dimensionality of the space, that we will come to know. Next, how many what you call instances are there, those many number of points will be there, or those many number of vectors will be there. This is what we can understand from the data. Now why we are discussing on this particular one is, once we transform this as vector, afterwards we will be considering only this what you call mathematics only to pursue or to retrieve the useful information. That is what the basic idea. From the data we are transforming this as vector. After converting as vector, we will be performing certain operations in order to get useful information. This is the idea. Yeah, is it clear so far? Thank you. Next, the matrix. As you can, you are more familiar with the matrix. Vector is single dimensional array. So as having mathematics or the programming language as a background, what can be the matrix? How we can define matrix? It is 2-dimensional array in general. 2-dimensional array. Single dimensional array we are considering as vector, or vector as single dimensional array. Matrix is nothing but 2-dimensional array So in one way, two-dimensional array we can consider as array of single-dimensional arrays. In each cell, we will be having single-dimensional array. That is the intuition for two-dimensional array. Now, how we can define matrix is nothing but collection of vectors, isn't it? So that is only the definition of matrix. Once if you have n number of here how many vectors we are having, m number of vectors we are having, each in n dimensional space. Each vector will represent n dimensional point in n dimensional space. This is the definition of matrix, right, in vertical with respect to this data. Now you consider some operations which you know already. I'm not going to discuss these preliminary things: addition, subtraction, scalar multiplication, matrix addition, vertical matrix multiplication, and all. And we can perform by using Python with this. Next, one important operation is this Hadamard product or element wise product. The name itself indicating. In general, when we can perform matrix multiplication is whenever the number of columns in first matrix is equal to number of rows in second matrix, then we can perform matrix multiplication. But this is a special operation, element wise product, where whenever we are having a matrix A with order, so let us say 3 by 4, B of order 3 by 4, then we cannot perform regular matrix multiplication, but we can perform element wise product where corresponding elements will be multiplying to get the resultant product. This is the idea, and this particular element wise product will be used for filtering or convolution in CNN. Okay, just for understanding, I am saying the definition. This is the application. I hope I am clear with this definition. If you have 3 by 4, 3 by 4, two matrices, we cannot perform regular multiplication. But if you perform certain type of multiplication, then we can get some useful information. What is that product is element wise product, where we will be performing element vertical corresponding elements product as the result. Like A11 in first matrix, B11 in second matrix. These two will be multiplying to get the element in the resultant product. Likewise, corresponding elements will be multiplying. This is called Hadamard product or element wise product. Next, this is matrix vector product. One matrix we are multiplying with the vector. So what is meant by matrix? How we have defined a matrix? Matrix is nothing but collection of vectors, isn't it? Now, and one more thing we have assumed that every vector we will be representing as column vector. If we want to represent as a row vector, then how will represent? In transpose form. Now, if you consider this A is a matrix. Here we will be having A1 transpose. This is a vector. A2 transpose. This is another vector. AM transpose. This is another vector. Likewise, we are having collection of vectors. So it is a matrix. Now, matrix vector product we need to perform. X is a vector, A is a matrix. Now we wanted to perform this one. Then what we can do is this vector we have to multiply with each and every vertical element in the matrix. Element in the sense that vector A1 transpose is considered to be a vector. Now, what is this Rm cross n? What is this one? Is, as we have considered, R power n is nothing but n dimensional space. Here we are having the space which is of order m cross n. Mn is the order of the dimensional space. So how many points we will be, or how many coordinates, or how many values we will be having to identify one particular point m into n. That is what the intuition for n dimensional or R power m cross n. Right. Next, consider a matrix product. This will come back afterwards because it is familiar to you. If time permits, we'll see. Next, linear combination, linear independence. It is nothing but if we are having a matrix, and matrix is nothing but collection of vectors. Vector is nothing but column vector we are considering. Now, if you consider one column is multiple of another column, then we can say these two are dependent columns, linearly dependent columns. Simply 1, 2 if you have, 2, 4 if you have in another column. In one column we are having 1, 2, in another column 2, 4 if we have. If you multiply this first column with 2, then we will be getting second column or another column. So these two are linearly dependent. Okay. Now let us see one example with this. Now if you consider 2, 4 as one column vector, minus 1, minus 2 is another column vector. So now collection of vectors is nothing but a matrix. Now this matrix we are having, this one first B1 is nothing but 2, 4 transpose. It is mentioned in row vector form. Next minus 1, minus 2 in row vector form. Now if you multiply minus 2 with B2, then we will be getting B1. So these two are linearly dependent columns. Now what is meant by linear combination is whenever we have certain vectors like v1, v2, v3, so on, vk, number of vectors like b1, b2, b3, so on, bk. If we are having vectors and there exist some constant coefficients a1, a2, a3, so on, ak, and these should not be equal to 0. And if you consider a1, b1 plus a2, b2 plus a3, b3, so on, ak, bk is equal to 0, then we can say that is linear combination, right? Now if you consider this another example I have, I guess, yeah, here in this C matrix C, we are having 1, minus 1, 0, 2 as first column. This is C1. Okay. Next C4, if you consider minus 1, 1, 0, minus 2. Okay. Is there any relation between these two columns, C1 and C4? If you multiply with minus 1, then we will be getting other one. C4 can be considered as minus 1 times C1, or C1 can be considered as minus 1 times C4. So these two are linearly independent. Similarly, C2 if you consider, C2 if you consider, C2 can be obtained by using this one, 3 times C1 plus 3 times C3. Okay, before considering this one, let us consider C5. C5 is nothing but minus 1 times of C3. C5 is nothing but minus 1 times of C3. So C2 we can consider as 3 times C1 plus 3 times C3. Why we are considering this one is, now C4 can be obtained by using C1. That is clear to you? Yes, C4 can be obtained by using C1. Next, C5 can be obtained by using C3. Right. Next, by using C1 we can obtain C1, C4. By using C3 we can obtain C3, C5. So by using these C1 and C3, if you can obtain C2 as well, then C1, C3 itself sufficient to get the entire vertical matrix. This is what the intuition. Try to understand. By using C1 we can obtain C4. By using C3 we can obtain C5. Now if you obtain C2 by using these two, if you can able to obtain, then these two itself sufficient, then we can say this is the linear combination, and we can say these these are linearly independent. Such kind of minimum number of minimum number of columns that we require in order to get all other columns, that is nothing but the rank of the matrix. What is the minimum number of columns that we require to obtain all other columns? Now if you consider this example, by using C1 we can obtain C4, by using C3 we can obtain C5, by using C1, C3 we can obtain C2. So C1, C3 itself sufficient to get all the columns. So how many linearly independent columns we are having? Only 2. So what is the rank of this matrix? 2. Likewise, we can conclude the matrix rank. So this is the idea. And in Python, we are having direct API matrix rank. If you call, then we can get the rank of the given matrix. Yeah. Next, matrix inverse. As you know, matrix inverse consists of so many operations that we need to perform. Like we have to know whether the matrix is singular matrix or not, adjoint, we have to find out all those things, you know. So I'm not going to the details of that matrix inverse, but I want to mention one point here. What is meant by orthogonal matrix? Orthogonal matrix in the sense, if the A inverse is equal to A transpose, then we can say that matrix is orthogonal matrix. Then why we need to study this these kind of properties in matrix, that I want to give some what you call intuition. Like suppose if you know one matrix is orthogonal, you need to find out inverse of the matrix, inverse of that particular matrix. Then what you will do? Simply you can use that what you call property of the orthogonal matrix. What is the property? A inverse is nothing but A transpose. So finding A transpose is relatively easier or simpler operation compared to finding A inverse. Definitely it is well known to all of us. Now A transpose, if you can able to find out, that will become A inverse. Now if a matrix is orthogonal, then you can say A transpose is nothing but A inverse. This is one thing. Suppose if the matrix is not orthogonal, then what we will do is we will try to make we will try to perform certain operations and make that one as orthogonal matrix. Then we can find the A inverse easily by calculating A transpose. That is the intuition behind knowing these kind of properties. If the determinant is 0, then we cannot have inverse, that is already known to you. By using those, we can eliminate certain things. But after coming to know that there exists an inverse, and if it is orthogonal, then we can find out A transpose, and we can find out ultimately A inverse. But if the matrix is not orthogonal and we wanted to find A inverse, then we will perform certain operations and we will make it orthogonal matrix. Then we will make use of that convention to find out A inverse. Yeah. Next, this is the what you call function call to find the inverse of a matrix. Next, eigen decomposition. This is another head I am keeping. Eigen decomposition, where we will be having eigenvalues, eigenvectors, orthogonal matrix, diagonalization, SVD, all these things. In this particular one, eigenvalues, eigenvectors, why we need to learn what I will try to give some intuition. Like to consider any number, let us say 65. 65 or any number you consider, that number can be factorized or can be written by having prime numbers as the factors. Like you consider 65, 13 multiplied by 5, isn't it? Likewise, you consider 64. 64 can be written as 2 power 6. 2 is the prime number. Likewise, any number if you consider, that number can be represented as product of prime numbers. That is nothing but prime factorization. Similarly, not exactly same, but similar with the similar intuition, you can consider vector, eigenvectors, eigenvalues. If you multiply with this, then we will be getting this eigenvector. We will be having A is the matrix and V is the eigenvector and lambda is the eigenvalue and V is the eigenvector. Like this, how you will find out eigenvalues, eigenvectors, this part I am not going to discuss. Just I want to give some intuition behind this eigenvalues, eigenvectors, and these eigenvalues, eigenvectors will be used, or eigen decomposition is used in dimensionality reduction. I will try to tell one example regarding this dimensionality reduction. Google page ranking algorithm also will be using this eigen decomposition what you call frequently. Yeah. Next, based upon this eigenvalues, we will be getting some properties for the matrix. Whether if eigenvalues are positive, matrix is positive definite, eigenvalues are positive or zero valued, it is positive semi-definite, or otherwise it is negative semi-definite. Likewise, we are having out of these positive semi-definite matrices are interesting in machine learning in general. Okay, and certain properties are there. If you multiply, the product of all the eigenvalues is nothing but the determinant of the given matrix. These are some properties you can go through with these. Yeah. Next, in this particular one, geometric interpretation of these eigenvalues and eigenvector. This is one of the important things. Now you consider this is the object that we are considering, let us assume, and this particular one we are scaling with respect to eigenvalues. Then after multiplying with respect to eigenvalues, this interpretation, this geometrical representation has been changed so that the dimensionality can be reduced. I will try to give one small example. Is my video visible? I hope it is visible. Now you consider this is one object. I'm showing like this. Now in this particular, now in this particular one, one object I'm showing from one end without just to assume there is no what you call assumption, what you call no information is known about this particular object. Then what you can see is only single what you call two dimension, we can say only two dimension. Now you consider you have turned this towards like this, just slight turning I'm doing. Then you could able to sense that some cap is there and some vertical. You can feel that it is a bottle after just by turning. Now also you could able to see only two-dimensional image, but earlier whatever the information you couldn't fetch it, that you could able to fetch it by doing this one, right? So what does it mean is whatever the object we are having, if you scale it in one particular direction, then we could able to get extra information. That is, without having three dimension for this particular object, you could able to make it two dimensional itself. You could able to get the required information that this is the bottle. I hope I got the I could able to convey properly. Yes, I'm trying to repeat once again. One object is there. One object I'm showing in two dimensional, and whenever we turn in other way, you could able to get extra information which you will be getting whenever you will be having other dimension. Now we are the same intuition here we are using. By rotating or by scaling, we could able to get the extra information within less dimensions. This is the intuition for dimensionality reduction. Okay, this is possible by using the mathematical concept called eigen decomposition. This eigen decomposition is based on eigen values and eigen vectors. Okay, I hope I have reached you. Yeah, and in Python we can get easily eigenvalues and eigenvectors. Like this is the matrix, and just if you call Eig, then we will be getting eigenvalues and eigenvectors directly. Yeah. Next, these are the applications for eigenvalues and eigenvectors. This is an important one. Dimensionality reduction, image compression will be using, face recognition will be using, graph embedding, anomaly detection. These all things are the application areas where we can use these concepts. Next, you consider analytic geometry. This is another head. Here again, one more inner product norms. These things will be discussing. These things are more useful. I'm not saying these are the limited to analytic geometry, limited to only these concepts. Just these are more useful tools. Now in this particular one, dot product, here in this dot product, again I want to shift to video one more time if possible. Please switch to video. Just you consider basic intuition. We are having um, one vector, one vector will be having the magnitude and the direction as we have discussed, and another vector is there, now we wanted to find similarity between these two vectors, right? Now what you do is just to add a line between these two like this. Just to assume a line is added between these two. Okay, and this is just straight line, and this is just we are assuming that this is just straight line. Then what is the angle formed at this particular place? Yes, at this particular place, what is the angle? Any answers? This is one vector, this is another vector. Here, now we are saying there is one straight line we are adding at this particular point. This is what we are assuming. Yeah, it is exactly 90 degrees. Yeah. With fingers, I could not say exactly, but it's possible. Yeah, this is one vector, this is another vector. Okay, now we are joining these two. Okay, what is the angle at this particular point is definitely 90 degrees. Just we are assuming. Now this is theta. Let us assume this is theta. Now you consider what this is x vector, this is y vector. Now let us assume this is some z, whether it is a vector or some other thing, that we will see later. Now you consider what is the trigonometric function which will give some relation between x and y. Which trigonometric function will give relation between x and y? Can you able to tell? We know trigonometric functions, sine theta, cos theta, tan theta, all those things, right? Now, what is the trigonometric function which will give the relation between these two with respect to theta? With respect to theta. For theta, what is the opposite side? Z. What is the adjacent side? What is the adjacent side? X, isn't it? What is the hypotenuse? Y. With respect to this right angle triangle, theta, opposite side is Z, adjacent side is X, hypotenuse is Y. Now, what is the trigonometric function which will give the relation between these two? Now you can come to consensus. Yeah, what is the answer? It is definitely the cos theta, isn't it? Now, cos theta is the one which will give the relation between adjacent side and hypotenuse. Okay, what is the adjacent side? X. What is the hypotenuse? Y. Right. Now you consider what is the range of cos theta. Cos theta values will range from -1 to +1, isn't it? -1 to +1. Yes or no? What is cos 0? What is cos 0? Cos 0 is 1. Cos 90? Cos 90 0. Now you consider cos 0 in the sense this y will be coinciding with x, isn't it? Cos 0 is nothing but 0, theta will not exist. That means y will be coinciding with x. That means x and y are more related, isn't it? X and y are same. Whereas if theta is increasing, then automatically x and y are deviating more, isn't it? Now, the idea here is whenever we are having some vector which is already trained, now this y is new one. Let us assume y is the new data. Now, whether this y is related to x or some other vector means we have to perform cos theta, then we will come to know what is the similarity between these two vectors. That is the idea. I hope I could able to convey properly. But the intuition why we are having why we are considering cos theta is here whenever one vector we have already trained, okay, whatever the data which is available, that entire data we are considering as vector. Now new data has come, we have to predict, we have to check what is the similarity. Then what we can do is we have to compare with the other vectors which are already available. So we will perform dot product. Okay, that's why the dot product is mentioned as this particular formula. This is the intuition. So whenever we have a dot product, whenever we perform dot product, then we will come to know what is the similarity between two vectors. Okay, this can be considered as cosine similarity. Okay, this we will be using very frequently in machine learning. And earlier while discussing about matrices, matrix multiplication we didn't discuss, right? In the matrix multiplication we will be having this what you call two matrices. Okay, call number of columns in this, number of rows in this should be equal, right? So why these need to be equal is we will be performing dot product. Dot product in the sense, let us say 2i plus 2j plus 2k is one vector, 3i, 3j, 3k is another vector. Then we will be performing 2 multiplied by 3, 2 multiplied by 3, 2 multiplied by 3. So dot product, we need to multiply likewise. Here, whenever we multiply these two, we are performing what? Dot product. That's why we need to have these two as the same. Then only we can perform dot product. That is the intuition. It is not simply like we are performing in this way. That's why we are the reason behind that one is we are performing dot product. That's why we need to have both the what you call number of columns and number of rows should be equal. Okay, this is the intuition. Yeah, and for the dot product we are having certain vertical applications for similarity measurement, cosine similarity, feature importance, projection, modal evaluation. All these are the applications for the dot product. Similarly, we are having another thing called norm. We will be you consider a vector like a 2i plus 3j or 2i minus 3j. What is the magnitude for this particular vector? Or in other words, what we can say is vector means we will be having direction in addition to magnitude, right? So whenever we are having a vector, what is the magnitude of that particular vector? That we will come will be considering as norm of the vector. Okay, and there exist several norms like it is nothing but vector to a scalar value. It is nothing but the magnitude, and there exist several norms which are useful, and generalized norm we can consider as LP norm. Just I will try to give one simple example. Just x is there. X can be represented as square root of x square. Is it fine? Square root of x square. Is it fine? Similarly, x cube can be same x can be represented as cube root of x cube. Is it okay? Likewise, we will be denoting LP norm. This is generalized form. Like we are having xi power p whole power 1 by p. That means x power p, let us assume it is 3, x power 3 whole power 1 by 3. It is nothing but x only, isn't it? But here we'll be having certain values for the x. Since it is a vector, we'll be having certain values, right? Three-dimensional vector means we'll be having three values. So those all will be adding, then we will perform this 1 by 3. Okay, that is the intuition. Just to understand the formula, I have given this intuition. Now you try to get the idea. LP norm is nothing but we will be denoting as x what we call subscript p, and summation of I is equal to 1 to n xi power p whole power 1 by p. This is LP norm, and this p can be any number. In general, we will be having 1, 2, 3, so on up to infinity. By default, if you don't specify p, by default we will be considering as 2. Okay, and we will consider that one as Euclidean distance. Okay, in the next slide I will be showing. Yeah, p is equal to 2, then it is called L2 norm, and we will be denoting as x2. And what is the intuition here? Square root of summation of xi square. This is the intuition. Okay, and we will denote this one as Euclidean norm. If you don't specify anything, then we can consider that one as L2 norm only. Okay, if you specify here 3, then it is L3 norm. If you specify 4, it is L4 norm. But if you don't specify, it is L2 norm, and we will consider that one as Euclidean norm. And if it is 1, then we will be having just a summation of all the values, that is 2i minus 3j, then summation of mod of the 2 plus 3, that will be the norm, L1 norm. Suppose if L infinity is there, then what does it mean is we will be finding the maximum. We will be considering maximum of all those 2i minus 3j. What is the maximum? Maximum magnitude 3. That will be the max norm or infinity norm. And L naught norm is nothing but how many non-zero elements we are having, that will be considering as L naught norm. These are some types of norms we are having, and every norm is having its own applications. I think we are having the definition article applications also mentioned in further slides. Just in Python, we are having direct functions to find out the norm of a comma 1. A is the array or the vector. Array, single dimensional array is nothing but the vector a comma 1. That means what we are finding? L1 norm. L2 norm means what we have to specify here? 2 we have to specify. But as we have mentioned, if 2 is not specified, then what does it mean? It will be considered as by default L2 norm itself. So norm of A means what does it mean? It is L2 norm only. Okay, we need not specify comma 2. Okay, next max norm means we will be specifying here norm of A comma infinity. Okay, likewise we can find out norm of a vector by using these functions. Yeah, these are certain application areas where we will be using norms, distance metrics, as regulation, as feature scaling, as convergence criteria. We will be using these norms. Yeah, next, orthogonal projection. This is similar to earlier what we have discussed. Here you consider one vector is there, this is another vector. What is the projection of this y onto the vertical, onto the vector x? So this particular one we have to find out. So the magnitude we will be having for this vector and the direction also. Now you can specify one thing, what is the what is the direction of this projection of y on x? What is the direction? It is same direction as x, isn't it? The direction of this projection of y on x is nothing but direction of x itself. Now what we are considering is, what is the magnitude? What is the magnitude? How we will find out is just by using cos theta we can find out, right? Why? Because it will it will gives the information about these two, this one and this one. So cos theta itself we can use. Then we will come to know cos theta is nothing but projection of y on x by the hypotenuse, that is nothing but norm of y. This is norm vertical symbol. Now what is the direction also we have to specify. What's the direction? Direction is nothing but this x direction. So totally how we can what you call consolidate is, projection of y on x is nothing but this is the magnitude and this is the direction. This will give the direction. Likewise we can get the projection. This is called orthogonal projection of a vector y onto vector x. I hope it's clear. Yeah. Next, probability and distributions. Here these are some of the concepts where we can find out so many applications in machine learning and data science area. Mean, variance, sum rule. I think I'm going out of the time, but I'm taking the privilege to take 2 or 3 minutes more to show some slides which are a little useful, which I have skipped while covering. See here, linear algebra. We have covered some of the concepts like matrix, vector, all these things, linear independence, these things. What's the relation among these and what is the application area where we will be using in machine learning and data science? In dimensionality reduction, we will be using these concepts. In classification, we will be using these concepts like this. Some summary we are having in these charts. Just I want to show once so that you will come to know whenever these slides are shared with you. Yeah. Next, you consider another thing, that is analytic geometry, where we have considered several concepts like eigen decomposition, eigenvalues. Here we have mentioned determinant, eigenvalues, eigenvectors, orthogonal matrix, diagonalization. These things will be used in dimensionality reduction. Next, you consider another thing like analytic geometry. Analytic geometry, here we have discussed about inner product, which is nothing but that dot product, and by using this we have calculated norm. By using this, orthogonal projection can be done. This can be used in regression, matrix decomposition, dimensionality reduction. All these are the application areas. Of course, classification as well. These are the application areas where we will be using these analytical geometry concepts. Next, of course, I didn't cover anything about a probability, but I want to show this slide, that is mean, variance, other concepts related to probability and distributions. Here, these will be used in dimensional reduction, regression, density estimation. All in these areas, we will be using these concepts. This is the what you call correlation among these concepts. Yeah. Some of the distributions also important, like Bernoulli distribution, uniform distribution, binomial distribution, Poisson and Gaussian distribution, which is nothing but normal distribution. You might be knowing this normal distribution, bell-shaped curve. Yeah. And coming to this optimization, you might be knowing that we'll be having minimization problems, maximization problems. We will try to minimize something in optimization, minimization problem. in general, in optimization, we'll try to minimize the objective function. In machine learning, we'll try to minimize the error. Okay, this is the correlation, how we can consider whatever the optimization techniques we are having into machine learning. Yeah, next some special points called critical points, where how the distribution and all going, like you consider stationary points can be minimum, maximum, saddle point, like this. Just I want to discuss about this particular thing to show how we can how we can give the intuition for using differentiation here. Like you consider we are having x, how this x is being changed, we need to know. Then we will be performing differentiation. Whenever the derivative gives 0, that is f dash of x is 0, that means those are considered to be stationary points. That means there is no change at that particular point. That's what we can understand. Right? So I'm repeating one more time. If the derivative, that means f dash of x is 0, that means there is no change at that particular point. If there is no change, then those points we can consider as stationary points. Okay, up to this one we will come to know by using single dimensional single differentiation. Now you consider at that particular, whatever the stationary point we are having, here it is stationary point, here it is stationary point, here it is stationary point. So out of these, some stationary points are minimum, some are maximum, some are saddle points. Okay, what are those? How we can find out is, after this point, let us assume it is a maximum point. Let us say it is maximum point. Whenever we claim it as maximum point, what is the change afterwards? Can we if you differentiate one more time, then if it is going, if it is increasing, what does it mean? It is not the maximum point, isn't it? Suppose if you assume one point as the maximum, if you consider afterwards, there should not be any change towards positive. If you perform differentiation one more time, it should not be positive side, isn't it? It should be negative side, then only it will be considered to be maximum. Similarly, on the other hand, if one point is minimum, then whenever we differentiate one more time, it should not decrease. If it is decreases, then it will not be the minimum. If it won't decrease, then it will be the minimum. Likewise, we will be considering second derivative. That's why we are having f double dash of x. If f double dash of x is greater than 0, what does it mean? It is the minimum. If f double dash of x is less than 0, then it is maximum. If it is 0, then it is saddle point. Okay, likewise we are having some extremum points, minimum, maximum. Okay, and a local minima with respect to this particular one, you can consider this as the local minima, but it is not the entirely minimum. And if it is minimum for entire distribution, then we can say it is global minima. Okay, these are some of the insights related to optimization. Sorry, is my presentation visible?
No, sir. Now is no.
One second.
Ah.
Sorry.
Yes, sir. Now is visible.
Yeah, this is the slide I want to show finally. This vector calculus, partial derivatives, Jacobian matrix, Hessian matrix, Taylor series. These will be used in these areas: regression, dimensionality, optimization, density estimation, classification. In these areas, these concepts will be used. Then these are some of the references which you can refer in order to use mathematics as the tool for getting more fruitful results from the data. With this, I want to conclude my presentation. Yeah, thank you.
Thank you, sir. From participant side, any question? You can unmute and speak.
Hello, sir.
Yeah, tell me.
Sir, what is the difference between data science and machine learning, sir?
Actually, data science is nothing but extracting some insights from the data. There we'll be using machine learning algorithms. That's it.
Enough. Okay.
So can we generate synthetic data, sir?
Synthetic data means?
Like suppose the data size is very less, suppose for some ML program, but we need to increase the size. Whereas the data available, which in that particular subject which we are dealing, maybe it's not enough to
That for that you can consider GAN, sir, generative adversarial network. GAN. You go through this particular topic, sir. GAN. That may be helpful for you.
Thank you, sir. Thank you.
In these 21 days, you will cover that machine learning and deep learning, artificial intelligence. Hello, sir.
No, ma'am. We will cover the data science tools.
Okay, sir. What are that, sir? Data science tools? The data science, including that machine learning, deep learning, artificial intelligence. Is it so,
The tools, using tools, you can solve the machine learning and the deep learning applications, ma'am.
Okay, okay, sir. Okay, thank you, sir.
Sir, I have a doubt, sir. Sir?
Yes.
Sir, I have a doubt, sir. Is there any possibility of applying NLP in this data science, sir? Natural language processing. Sir, am I audible?
Yes, yes.
Is there any possibility of applying NLP in data science, sir?
Both are parallel domains. You can use some of the techniques.
What kind of a technique it can be?
What problem we are considering basically in NLP depends on that. You can specify that.
Thank you, sir. Thank you, sir.
Hello, sir. Good evening, sir.
Yeah, good evening.
Sir, I have a doubt about these mathematical formulas if we want to get out of the research, sir. So, like you told so many like eigenvalues and all. So, how can we apply to our research topic, like if we are going with any specific topic? So, any correlation, sir? How can we write the formulas out of these?
It's not like simply there will be some method to write. Sorry to tell like this, but the thing is, we need to know first of all what is the intuition behind those mathematical concepts thoroughly. Then, while addressing the problem, then we'll get to that idea. At this particular context, we can bring that mathematical concept into picture. Then we can use that formula directly. It's not like our own formula will be what you call will be evolved automatically. It is like a small extension to already existing formula. That is what you can observe by referring some research papers. Altogether, there will not be new formula which will be coming, but it will be some extension.
Yeah. Okay.
Finding that base requires a lot of background time.
Okay, sir. Okay. Thank you, sir. Thank you.
Good evening, sir. Sir, why Gaussian distribution plays vital role in machine learning algorithm rather than other distributions, sir? Is there any specific reason?
It's like I have mentioned one of the things like that A transpose finding A inverse. Finding A inverse I have mentioned like finding that directly is difficult. But if you convert that matrix into some other form, then finding A inverse is easier. Likewise, that Gaussian elimination will give easy solution for so many such kind of problems. That's why it is becoming widely used. I'm talking in terms of mathematical calculations. Is it clear, madam?
Questions?
Sir? Hello, sir.
Yes, sir. Yes.
Sir, when a student is not good at mathematics and he want to practice data science means whether he need to know the things you shared here, or is there any other way to practice data science?
For data science means one should learn mathematics, sir. That is the only available solution, I guess, sir, as of my understanding. For machine learning means they can go with existing algorithm. They can apply to some domain specific, domain related problems and all, and they can get some fruitful results or some results they may produce. Data scientist means definitely they need to know underlying intuitions and all.
Whether they should be advanced learners or beginners is enough, sir.
Beginners is enough, sir, but they need to have that patience and good source of getting the concept clear.
Okay, sir. Thank you, sir.
Everywhere this matrix product or matrix multiplication dot product, all these things everywhere available, sir. Even in our childhood we learned, but the thing is how we are considering those as formulas, we are considering as with intuition we are learning. That makes the difference.
Thank you, sir.
Sir, good evening, sir. Sir, your presentation is nice. Time only the concern. Sir, if possible, you may please suggest some website or any app or YouTube link for understanding the concept from beginning. It's the bottom of the concept about data science. You may suggest some of the website or any other app like YouTube channel, like website like WP School, like that. You may refer from your experience, sir. Sorry.
Okay, you please write to me, sir. You can find my details in NIT Trichy website. You please write to me. I will reply back.
Sir, sure. Thank you so much, sir. Thank you so much.
Good evening, sir. I'm from Humanities.
Good evening.
Sir, I have a doubt in what are some specific applications of eigenvalues in data science, and how do they contribute to the tasks such as dimensionality reduction, clustering, and recommendation system?
I have mentioned in the slides, right?
No, sir, I'm just asking for the applications.
Applications only I have mentioned, actually. A dimensional reduction and all I have mentioned, right? Just a second. What? Yeah.
Particularly in which applications you are using, I'm just asking for it.
In which applications we are using? I hope this slide will answer you. Yes, sir. Hello.
Yeah, sure. One second.
Hello.
Hello, sir.
Yes, sir. Thank you, sir.
Okay.
Hello, sir.
Yeah, tell me.
Sir, what is the ANOVA testing, sir?
I don't have much idea about it, sir.
Hello, sir.
Just tell me, sir. Hello. Hello.
I have a doubt, sir.
Yeah, tell me.
So if I'm giving last number of data sets to check whether to rank a word, which one is the best, sir?
Come again, madam.
I'm giving last number of data sets to verify, sir. So if in that case, when I'm searching for a word to be ranked under, which one is the best, sir? As you have said.
This, you mean what you are expecting, like the algorithm which we will be using for searching the word in a large data set, or
Yes,
which
sir.
concept we will be using?
No, the first one, sir. The algorithm.
PageRank algorithm will be using, right?
Yes, sir. There are lots of
PageRank.
algorithms are there, sir. But for collection of data sets, to in particular word, I'm going to search it. What will be the best one, sir?
That I don't know, madam. This moment.
Yes, sir. Okay, thank you.
You can write it to me. I will use some relevant answer.
Sure, sir. Thank you so much, sir. Please send your mail ID after this. Session.
Okay. I will.
Thank you, sir.
Yeah. Is the slide visible?
Sir, please share the feedback link once again, sir.
Yes, ma'am.
This is the mail ID. You can write it to.
Excuse me. Good evening, sir.
Yeah.
Sir, do differential equation have any role in data science, sir? Differential equation. Second order differential equation, third order, solving that. Because so many applications in Max is related with differential equations. But in data science, it has any role?
Of course, madam. I have mentioned, I think we have skipped that.
Actually, probability, everything you have mentioned, sir, that a differential is single derivative you have mentioned in that. But
It's
higher
there,
order
madam.
derivatives.
Higher order also we have seen, right? Saddle point, minimum, maximum.
Okay, second order, second order.
Second order we have seen. This slide you can refer, madam.
Okay, sir. Thank
Actually,
you.
the thing is, every algorithm, every machine learning problem algorithm, that problem will be reduced to one optimization problem. For optimization problem, again, whatever the techniques we have, those all will be useful. I can give you some 2-3 here. You can observe. Finding gradient of loss function, partial differentiation we will be using, Taylor series, chain rule, derivative. These we will be using for these applications.
Okay, sir. Thank you. Thank you so much.
This slide I didn't discuss, sorry.
Thank you so much, sir. The rest of the participants, those who have got queries, please post it in the group. We'll just share it to our professor over here. Or you can just mail Pavan sir, as he has mentioned his mail ID. Sir, thank you very much for your presence today. It was really valuable. You just started from the scratch. You just gave a wonderful explanation. And you've just covered calculus, linear algebra, statistics, and probability, that too in a very short time. We obviously, our participants will not be having like this time is not enough. We'll have a separate session with you in the future so that we'll have more idea, and we'll just enlarge our perception towards and putting data science with the mathematical foundation, as the title perfectly suggests what you have just put on. Thank you so much for your time, sir. It was wonderful having you.
Thank you.
Thank you, sir. Pawan, sir. Thank you for accepting our invitation, and you delivered the wonderful session today, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.